Well, hello guys, here Mr. G. We're going to be doing a question on acid and bases. This time is going to be a question from an informal test set up by Professor Rodriguez, so you can practice for the exam. This is question 2, and the question says the ethanoic acid reacts with sodium hydroxide to form sodium ethanoate, as shown in the following balanced chemical equation. There is the chemical equation, guys. Define an acid in terms of Lowry-Brønsted theory. And all you have to say is that an acid is a proton donor. Is ethanoic acid a weak or strong acid? Give a reason. Now, ethanoic acid is a weak acid. Now, why is it a weak acid? Because it ionizes incompletely in water. So what do you have to say? Because it ionizes incompletely in water to form a low concentration of H3O+. That is the answer for this question. The pH range of some indicators are given below, and they give you 3 different type of indicators there. Okay, so now which one of these above indicators would be best suitable for the titration of ethanoic acid with sodium hydroxide? Explain your answer. Now, what is important to know? We have a weak acid and we have a strong base. Alright, now how do we, this is strong base because it's a sodium hydroxide. It's a group 1 metal hydroxide and all of them are strong bases. Therefore, we're going to end up with a solution here that is going to be a weak base. So if you have a strong acid, a weak acid and strong base, the product here is going to be a weak base, which will have a range greater than 7. So which one is the one most suitable to use? There it is going to be phenolphthalein because of the range. So we use phenolphthalein when you have a combination of a strong base and a weak acid. So the answer is phenolphthalein because the pH of the salt is more than 7. That is the answer for this question 2.1.3, which is also here related to the type of acid or base we have in the equation. It's a very good question that side. Now this one is a very tricky stoichiometric calculation. It's a very good one. The standard solution of a 0.12 mole per decimeter cubic of sodium hydroxide is prepared in 500 centimeter cubic of volumetric flask. A learner dilute 50 centimeter cubic of this solution with 200 centimeter cubic of water. 18 centimeter cubic of this solution neutralizes 25 centimeter cubic of nitric acid. This is a lot of solutions here, and it's very confusing. The balance equation for this reaction is that one there. Define the term standard solution. And a standard solution is a solution of which the concentration is precisely known. Now this is the one that can give us problem here. Calculate the concentration of the nitric acid. Now for this question, the first thing we are going to do is to calculate the number of mole we have in the standard solution known. Okay, so this one is we're going to solve that question here to see if we have a space 2.2.2 because it's lot of calculation. So for the standard solution, we know the concentration, which is equal to 0.12 mole per cubic decimeter, and we know that it was prepared in 500. The volume was 500 cubic centimeter, but we cannot work with cubic centimeter. We have to convert. You divide by 1000. If you don't remember, guys, this one is decimeter cubic. Okay, now using this one, we are going to calculate the number of mole that they are in that specific solution there. Okay, so we're going to calculate that one there. Okay, so now this number of mole here, guys, is using the formula of concentration equal to number of mole divided by volume, and therefore the concentration is 0.12, right, is equal to number of mole divided by 0.5. So when you do that, the number of mole here is going to be equal to 0.06 mole. That is the amount of mole in that specific volume. But be careful, because now the learner gets 50 cubic centimeter from here and then dissolve it in 200. So now the new volume is going to be 50 cubic centimeter. The learner takes this volume here of this substance and use it or dissolve it again. So we need to know what was the number of mole in 50 cubic centimeter of that concentration. So this here is important to know right now, and that is the first thing we're going to quickly do here. The concentration is equal to number of mole divided by volume. Now this volume is the 50 cubic centimeters, guys. So if you substitute here, you have that the concentration is the same here for the 50 centimeter cubic. So it's going to be 0.12 is equal to the number of mole we're looking for divided by 50. You divide by 1000 is 0.05. Right? So the number of mole that we get in 50 cubic centimeters is going to be 0.05. 0.006 mole. I'm doing the calculation as I'm making the video, guys, to make sure the calculations are fine. Now, this number of mole is going to be the one in the 50 centimeter cubic. So we do have to calculate the new concentration for the total volume that is going to be now 250. So from here, the learner add that amount of mole to 200 centimeter cubic. So this concentration is going to be new concentration, which is going to be equal to number of mole divided by volume. But this volume here now, guys, be careful, because it's going to be the addition of that volume. There is going to be 200 plus 50 is the 200 that he dissolved here plus the 50 that is taken from there. So this new concentration is equal to number of mole that was calculated in the 50. So it is equal to 0.006 divided by the volume. The volume is going to be 250, so it's equal to 0.25, guys. So when you calculate that concentration there, it's going to give you 0.024 mole per cubic decimeter. Now this amount is important. This is the concentration of the solution that they use here. So they say here in the question, we're going back to the question, they say 18 centimeter cubic of this dilute solution. So the amount of this one that was used now with this concentration was 18 cubic centimeter of this solution neutralizes the 25. So the amount that was actually used of that specific solution for the standard one, okay, which is the sodium hydroxide, this one here, the volume used here was 18 cubic centimeter of this concentration, which is 0.024. This one is a very, very good question. So this is the amount that was now used to neutralize the acid. So we have to go back now and calculate the number of mole of that specific 18 cubic centimeter number of mole in there. So that is what we're going to do on this side here, using the same formula. So I'm going to now use the same formula. Concentration is equal to number of mole divided by volume. The concentration was calculated is the 0.024 is equal to number of mole divided by the volume is 18. Remember, you divide by 1000, so it's 0.018. So the number of mole here that you get is going to be equal to, and it's a very small number, so it is in scientific notation, is 4.32 times 10 to the minus 4 mole. That is the amount of substance you get there for sodium hydroxide that neutralizes the nitric acid, guys. So now what we are going to do, we are going to use the ratio. Now we're going to use the ratio on this side here. ratio of NaOH to HNO3. The ratio is 1:1. So the number of mole of the nitric acid that was neutralized is the same amount. So it's 4,32 times 10 to the minus 4. And using this one, we can now calculate the concentration of the nitric acid using the very much same formula we've been using up until now, guys. So we are going to use it on this side here on top. I don't want to make a lot of things here, but we're going to use this little space there. So concentration of the nitric acid is equal to the number of mole divided by the volume. The volume is given to you. It was neutralized 25 cubic centimeters. So when you substitute here, you get that is 4,32 times 10 to the minus 4 divided by the volume, which is 0,025. Remember, you have to divide by 1,000. So the concentration of the nitric acid at the end is going to be equal to, let's make space there. So the concentration of the nitric acid is going to be equal to 0,017 mole per cubic decimeter. This is the final concentration of the acid. Guys, I hope you understand. This is a very, very good question. It's a lot of calculations from one side to another. I love this question. It's a good question for the upcoming exams. And then to end this question, let's calculate the pH of the nitric acid. Alright, now for this question, what do we have? We have the concentration of the nitric acid that just was calculated. Now remember, the nitric acid in previous videos we talked about that ionize in water to form hydrogen ions and nitrate ions. Alright, now what we need to know, because remember the pH is equal to minus log of the concentration of H3O plus or H plus. Alright, and what we have here is the nitric acid, so we cannot substitute. So now we have to go to this ionization reaction and see what is the ratio of this one is to that one there. You can see the ratio is 1:1 here, so the concentration of this one will give the same concentration of that specific ion. That's all you need to notice there, and it's quite simple. So all you have to do here now is to substitute minus log multiplied by the concentration, which is the ratio is 1:1, so is 0,017 there, guys. Please note, I'm going to write it here on this side, the ratio. This is going to be ratio of HNO3 to H plus. And because the ratio is 1:1, therefore the concentration of this one will produce the same concentration of ions in the. This is important, and that is why we end in that substitution there. And when you substitute this one and you punch in your calculator, guys, you get that the pH is equal to 1,7695. This is the pH of that nitric acid. You can see it's a high pH. But guys, this is all for this question. I hope you understand. It's a very good question. Thank you for watching. Subscribe for the channel. I see you next time. Next time we'll be solving another acid-based question. I'll see you next time, Mr. G.